the theory behind how robots sense, think, and act. A robot is a machine that can sense its environment, process information, and perform actions in the physical world. At a theoretical level, robotics is about understanding how machines can interact with reality in a structured and intelligent way. Every robot is built from three fundamental components: sensors, a control system, and actuators. Sensors are devices that allow robots to perceive the world. Cameras provide visual information. Microphones capture sound. Distance sensors measure how far objects are. Touch sensors allow robots to feel contact. The control system is the decision-making unit of the robot. It receives information from sensors and processes it using algorithms. These algorithms describe how the robot should behave under different conditions. Control systems can be simple or complex. A simple robot might follow a fixed set of rules. A more advanced robot may use feedback loops, probability, and learning-based methods to decide what to do next. Actuators are the parts of the robot that create movement. Motors rotate wheels. Hydraulic systems move heavy robotic arms. Servos control precise joint movements. The relationship between sensing, thinking, and acting is often described as a perception-decision-action loop. The robot senses the environment, decides what to do, and then acts. This loop repeats continuously. One major theoretical challenge in robotics is uncertainty. Sensors are noisy and imperfect. The real world is unpredictable. Therefore, robots must reason with incomplete and uncertain information. Robotics also involves modeling the physical world. Engineers create mathematical models of motion, forces, and geometry. These models help robots plan how to move without colliding with objects. Another key concept in robotics is autonomy. An autonomous robot can operate without direct human control. The level of autonomy can vary from simple automation to complex independent decision-making. Robotics combines ideas from mechanical engineering, electrical engineering, control theory, computer science, and artificial intelligence. Robots are used in manufacturing, medicine, space exploration, agriculture, and service industries. As robots become more intelligent, ethical questions arise. How much control should machines have? Who is responsible when a robot makes a mistake? Understanding the theory behind robotics helps us design safer and more reliable systems. In future videos, we will explore robot perception, motion planning, and robot learning in more depth.